Okay, we're being told that we can slowly start the talks. Yeah. Are we good on audio? All right. All right. Thank you very much. I think we can start. We've been told by people online that it's okay to start this talk. So, all right, I'm going to be the first speaker, then I'll be handing it over to Fergus from Titan, who then will be handing it over to Isabel from Jina AI. So I'll quickly start introducing what I'll be talking about. I have a pretty sure of itself title for this talk, which is either a good or bad thing. And I'm going to be talking about having large language models, or specifically LLM pipelines, and we'll see what that means, generate structured outputs, but most importantly, generate validated structured output. And we'll see what that means a bit as well. Before I jump into that, a bit about myself. My name is Tuana. I work at DeepSet. DeepSet is a company that builds the open source LLM framework Haystack. And I mainly work with the Haystack team. I'm in the developer relations team. You can find me on practically all social media if you really want to. And I am based out of Amsterdam, so I'm in London just for this meetup. And what I'm going to do is, in no particular order, by the end of this talk, I would have covered these main topics. Using large language models to extract information in a structured format, validating that output, and specifically with Haystack, because I'm going to be building this with Haystack, we're going to be looking at looping pipelines and custom components, and we'll see what that means in a bit as well. All right, so to set the scene as to what's going on here, this whole presentation is actually based on a tutorial two of my colleagues wrote, and you can find that on the Haystack website. But I thought the tutorial could be used in a slightly different way as well. The idea was, well, does everyone know GitHub? I'm presuming that most people here know GitHub. We have a lot of chats internally, meetings, etc. Wouldn't it be cool if, based on some meeting notes, or maybe even transcribed meeting notes, if I could extract key bits of information, because most probably we're going to be creating some GitHub issues. Could I extract some key bits of information that can create those GitHub issues for my repository? So here's like a conversation that I typed out. This is fake, but this is some conversations that we've actually had this week. So there are two things going on in this transcript here. One is about a bug that we found in a BM25 retriever that needs fixing. And the other is about a new feature we want to add to one of our document stores, which is the Chroma document store. And there's a whole, chat between two people. But the main information is in these few lines. There's a bug, BM25, we want a feature, something else. So the idea was, well, wouldn't it be cool if something could just sort of, extract that into a JSON format and actually create those GitHub issues? And a few things to know about GitHub issues and repositories is, at least as far as I have been able to understand, is you can't just create a REST API request that asks for you to create an issue with any label. Usually repositories look a bit like this. This is ours, and there are some labels here. And those labels have to exist. It has to be the actual labels that are in this particular repository. So you can't just, label it whatever. You can't hallucinate a label. And then the other thing is that the request you send also has to be of a particular format. So here's like a screenshot of all the information that's required to create an issue using the GitHub REST API. So that's just to depict to you the problem here. You can't just send any sort of JSON body and expect an issue to be created. So the idea behind this quick demo is based off of this tutorial, where if you scan that QR code, it'll take you to the tutorial that's actually building the little video you're seeing here. It turns out that large language models are actually quite good at generating structured outputs, but whether that structured output is in the format that you need is a different question. But there are tools out there that you can use, and we were using Pydantic. And the situation we've got here is that we've got a base of Pydantic model called cities data, which says it's a list of cities, and every city needs to have a name, a country, and population. And just telling large language model, Berlin is the capital of Germany, and just produce this structured output works, but not all the time is that structured output abiding by what you need. So the idea behind this tutorial is that we use Haystack's pipelines that are able to loop to tell the large language model where it went wrong and to fix it. So we loop until we fix the structured output, using a component that is able to validate the produced structured output using Pydantic. So that's the general idea behind it. So for my demo, what I need is, ideally, I've got meeting notes, and I can provide some JSON schema as well. And then I'm providing that to some LLM. So I'm used OpenAI for this particular example, but imagine you switch this over to any other model. Not all of them will perform the same. For this demo, OpenAI's GPT-3 and 4 seem to work pretty well. And that's going to produce some output. But what I want to do next is I want to give that output to a validator, Pydantic validator. And if that says, okay, fine, that would be fine. But if it says no, I want it to loop back and tell the LLM, you went wrong, this was why it was wrong, try again. And then we do the pipeline all over again. And if it's okay, it's okay. Which brings me to Haystack. So Haystack is our fully open source LLM framework. It's all built in Python. The idea behind Haystack is that it provides very sort of nuclear little tools for developers to build out their own custom NLP pipelines. And the building blocks in Haystack is largely called pipelines and components. Pipelines are made up of components where every component is funneling data to the next component. And a component can be something very simple. It can be something that's doing embedding retrieval. It could be something that queries a large language model, and so on and so on. I'm pretty sure lots of people here have already heard about the term RAG now, Retrieval Augmented Generation. So this is what a classic retrieval augmented generation pipeline would look like. You might have a query, and we embed that query in some way, and you can use, for example, Jina AI or Hugging Face models, etc. Then you would use a retriever that retrieves the most relevant documents to that query from a database that you might be keeping all of your documents in. This is why it's called retrieval augmented, because then we use those documents. In the Haystack world, we call this prompt builder. You build out a whole prompt that has both the query and the relevant documents. And then you generate some output, some answer. And that can, again, be from many different LLMs. But another thing I want to add about Haystack here to explain how we're going to be building this application is that pipelines don't have to be like a one-way road. Every component can also have multiple outputs, and we're actually going to use this for our output validator, because the output validator is supposed to tell us you were right or you were wrong. They can also loop, and this is again something else we're going to use for this application. And another important thing about Haystack, so a quick side information, Haystack is going through a major upgrade. Haystack is becoming Haystack 2.0. So all of the code snippets you're seeing here are from Haystack 2.0. The idea behind the framework Haystack is that we provide a bunch of components for you. That can be a Google Vertex AI generator. It could be an embedding retriever and so on. But the idea behind the design of the framework is that we don't assume to know what you might need. For example, the other day, I built an application and I needed something that could fetch Hacker News articles, and I want to use that in my pipeline. So we have a way to build custom components. And here is a very simple custom component that is a valid component, by the way. And you can see that it just needs the decorator components around the class, and that class needs a run function. The other thing that run function needs, it needs to output something. And we actually also tell the pipeline, you can see the component output types, and this is used for pipeline validation. We tell the pipeline that this component, we expect to get out of it something called documents, and that's a list of documents. We're also going to be using this because we'll be using an output, we'll be creating our own output validator, basically. Final thing to know about Haystack is the way we build prompts. I think this is very common now in lots of frameworks, so hopefully it's not very foreign. But here you have some different styles of prompts. Usually it starts with an instruction, but the important thing is mostly the things that you see in those curly brackets. These things become inputs to basically the large language model. So in this case, for question answering one, you're telling the prompt builder that I expect input called context and I expect input called question, and so on. This is all Ginger templating, by the way. All right, so I have a recipe now to build my validated structured output generator. The first thing I'm going to do is I'm going to build my own validator because Haystack does not have it. I'm then going to create a very clever prompt. It's going to look like a lot on the screen, but I'll just show you the important parts. I'm going to need an LLM. That could be one of many LLMs. I'll show you some of the options in a bit. And then finally, I need a pipeline to stitch all of these together. So the first thing we did is build an output validator. You can see the decorator component at the top here. And I've redacted most of the code. All of this is in a working collab, which I'll be sending over to everyone, so you can try this yourself too. I've redacted a lot of code, but you can see that the run function has a try and accept. So basically the try is saying, you know, Pydantic was validated. This was the correct output for me. This is also to initialize this component. We're also expecting a Pydantic model to be provided. And the try says, okay, it was valid. The replies were valid, and this is your output. But if we hit accept, then we're returning both the invalid reply and the error message we got from Pydantic. I also then went ahead and created my own model. And this is not true, by the way. Haystack, the Haystack GitHub repository does not have these exact labels, but I just made some up. So I've basically listed, I think, 6 labels here. An issue is meant to have a title, description, and labels, a list of label, and then issues are made up of a list of issues. And then I initialize an output validator. Then this is the very long prompt I was talking about, but the important part of this prompt is what I've highlighted here. So we're basically telling whatever large language model we end up using that it should expect meeting notes and a schema. And then the cool part is that you see a big if block there. So it might get invalid replies and error message. And if it only gets those error messages, this is what helps us do the looping, by the way, then the prompt slightly changes. The prompt adds a section that says, you already created the following output, it was wrong, and this is why it was wrong. And then I create a generator. In my particular case, I did use GPT-4, but this QR code should take you to everything else in Haystack. This is just one of the many options. I think you could also use Mixtral here. Probably I haven't tried it with Mixtral, but you can use the Hugging Face TGI generator and try it out with that. You could also use the Gemini models. But yeah, I went with GPT-4. And then finally, the pipeline to stitch it all. I'll switch over to the collab in a bit to see how I've done this. But what this is doing here is you can see 2 user inputs that are expected on the far left-hand side, meeting notes and schema. This is provided to a component called prompt builder. That's the long prompt you saw. Then we're handing that over to our generator. And then I've made the output validator a different color because remember that wasn't actually from the Haystack framework. I built it myself. And then the output validator either returns valid replies and we're all done, or is providing invalid replies and error message. And we can actually set how many times we allow this loop to happen in our pipeline. I think the collab I'll be sharing, it's set to 7. So it'll try 7 times, but then this is just a safety guard so that we're not making an infinite amount of calls to OpenAI. You can try this whole thing in collab, it works, but I can actually, hopefully I've still got it up, but it's not easy to switch over here. Does anyone know how I can maybe remove this thing? This one. It's fine, we can do that instead. I'm not going to run this whole thing because it'll take time, and I'm also very nervous about running things live. But you'll get all of this. I'm going to send it over to everyone. And if hopefully it's not gone away, if I scroll down, okay, you'll see that number one, maybe this is interesting to see. The way I create the pipeline is by adding my components, and then I can be very explicit about my connections. So this is what's one of the main things that's actually been changing from Haystack 1.x to 2.0. So here I can say that the output validator, invalid replies, and error message are the things being forwarded to the prompt builder's invalid replies and error messages. And then finally, I can run my pipeline by providing my fake meeting notes and the JSON schema. And you can see that actually the first few tries, even with GPT-4, it wasn't the exact output that we needed for Pydantic to verify it as the correct format. But at the end, I did get 2 issues, and these are pretty good, actually. I got add persistent memory to Chroma document store, and it was labeled with document store and feature, which is nice to see. And then I also got something labeled bug and retriever. So we're also making sure that the labels abide by the labels I meant to have for my repository. And that is it. I can switch back here, and this is all of the resources that you might need. Please feel free to use the collab and let me know if you break it. And I think we can take, maybe if there's any questions from the audience, maybe we can take a few questions, and maybe one from the Zoom call as well. I think we have another mic here as well. So maybe someone from Zoom can tell us if the mic actually works. Can we hand it over?
Thanks. So I have a more theoretical question. Do we know if forcing the model to output JSON affects the quality of the results?
Well, I guess that's a self-fulfilling question. So I think asking the model to create JSON, I think from my experience, a lot of these models, especially OpenAI models, are really good at generating JSON, if that's the only thing you need. What they're not so good at is making sure that that JSON abides by what you need the structure of that JSON to be. So that's what we're kind of fixing here, and that's why we do the looping to make sure that it can try again with the context. That's important. They're good at fixing when they get the context as to what was wrong with the output they generated. At least this is for GPT-4. Yeah.
Thanks.
There's another one over here. That's done completely by Pydantic. Pydantic is okay, maybe I should repeat the question. How do you detect what is actually wrong, was the question. That is done completely by Pydantic. That's why we create the output validator, which offloads that job to a framework that is designed to validate structured outputs. I think the collab also has some links to Pydantic. Pydantic is quite good, and we actually created that model with the labels, with a list of labels and how my issues are supposed to be created. Those are all based on Pydantic models as well. So we offload that job to a completely separate framework, which is nice because then in our pipeline itself, even though Haystack doesn't have any Pydantic components, by creating that custom components, I'm being very precise as to what my pipeline should do. The large language model isn't deciding necessarily to use Pydantic at all, because the pipeline is dictating that you've got a reply, now Pydantic validates that, and you loop back or not. Yeah, so that's the, now maybe switch over to this. The prompt actually has an if statement. So the prompt is changing or not changing based on the fact whether there is an invalid reply or not. So if the output validates, and we know that we're going to get invalid reply or valid replies because that's just what that piece of class does. It has a try except method. So we know we're going to either get an invalid replies from the component or not. And if we don't, that's where it ends. The prompt doesn't change. But if we do, then yeah, the prompt is actually modifying itself for the next loop. Are there any questions from Zoom? I don't hear that.
Sorry, my bad, I didn't turn the mic on. The question was, how would you integrate a hallucination detector to these pipelines?
Ooh, to this specific pipeline or pipelines in general?
Maybe you could touch on both topics.
Okay, so hallucination detectors, we actually use that in DeepSet Cloud in a way as well. There's various ways you can use that. So you could have, once your pipeline has generated something, one cool way to detect whether there's hallucination or not, actually it's interesting because whether the content of the answer is technically correct, what we actually want to check is whether it's based on our own documents and our own information that we fed in to the large language model. So in one way, you could potentially have a separate model that is able to tell you whether that output is entailed in your own data set. Or even more precisely, you can go further and you can ask it to tell you whether it's entailed in the retrieved documents. Because technically, if it wasn't entailed from the retrieved documents, the model still has hallucinated because it didn't generate the answer from the documents that were embedded into the prompt. And from there, you can get a score as to whether there is any hallucination in the output or not. Maybe we can also send over everyone. There is a demo on this on Hugging Face by one of our colleagues who detects whether the replies to questions are entailed from the retrieved documents or not, and all of the documents are based on rock music. So you can ask it questions about, singers and songwriters and various bits of music, and it will tell you how much the produced answer from a generative model is entailed from the documents that were actually retrieved from the data set. So that is definitely a possibility. And I think I'm just on time. I can probably hand it over to you folks. Thank you very much. I have some hold on close.
Here we go. Hi, can everyone hear me okay? All good? Okay, great. Okay, well, hi everyone. My name's Fergus Finn. I'm the co-founder of TitanML. And I'm going to talk today about challenges in serving LLM applications at enterprise scale. And that's something that we focus on at TitanML. That's why I'm going to speak about it. So let me just get started here. Okay, so LLMs are really good. I don't think this slide is going to surprise anyone in this audience. LLMs are fantastic at the job that they do. And day-to-day operations at enterprises all over the world are dominated by this task of text processing that LLMs are so good at. And this product solution fit is materialized in this graph here. ChatGPT is the fastest, or at least it was until Threads came along, the fastest growing consumer product in history. So yeah, LLMs are really, really great. But if you're building an LLM application today, there's two different paths you can go down. You could choose to build on one of these API-only models, GPT 3.5 for Claude, Pi, Mistral Medium, GPT 3.5 for the models behind ChatGPT, the reason for this astronomical growth. But there's this new frontier of models coming out, these open source models, Llama 2, Mistral, etc., that are starting to show real growth in their capabilities and ability, right? And part of what I'm going to try and convince you of today is that that growth in ability is worth building on, even though GPT 3.5 and 4 are amazing. There is much more you can do if you can look beneath the surface of those APIs and build on open source models directly. And here we are. So API models have major drawbacks. You're stuck behind this API surface, and that API surface defines what you can do with the model they give you. So that model is one size fits all. everybody in the world interacts with GPT-4. And so if someone somewhere needs it to be able to do something that is significant enough contingent, then OpenAI will focus on that and make that true forever, even if it doesn't help you with your use case. It will write Shakespeare, even if you just need it for Python. Privacy and security is a concern a lot of people have, sending your information away from your business to someone else. If you work in the health sector, finance sector, control and auditability. OpenAI is great, but you're stuck dealing with text coming from the model. You can't get into the internals. You can't check that it's doing what you want it to be doing, and it will change over time, right? And they will change it over time from under you. You build your business on OpenAI, it will give you great results on day 1, but on day 25, they need to cut the size of the responses to save their GPU budget. Suddenly your application will need some shifts, some re-architecture, and that's something you can build around, but it's a constant burden for your dev team. And you can't modify their behavior. That's somewhat true. You can fine tune some of these API models through their APIs, but you don't have the level of control that you do with local models. But the concern you might raise is, well, our open source models aren't good enough yet. They're not the same as GPT-4, and that's certainly true. But that's not going to be true forever, right? Open source models are getting better every day. If you have domain-specific knowledge and you know how to embody it in your model, open source models are already better. If you fine-tune Mistral, Mixtral, and you know how to make that fine-tuning fit your domain, then you can get better performance on most tasks than you can get with GPT-3 and GPT-4. And beyond that, the number and scale of open source models is exploding. Every single day, seemingly, there's new models coming out. And they're getting bigger and bigger every day. I mean, this came out last week. This was Mark Zuckerberg's announcement about Meta's training facilities for OpenAI. For AI in general. I don't think that they're helping. They've bought 350,000 NVIDIA H100s. Yeah, it's a lot of money. It's a lot of energy that they're using to pursue an open source strategy. So lots of things are coming out. And open source models are good. They've beaten GPT 3.5, depending on your definition of beaten. But if you use Mixtral, you can certainly get performance that's comparable. And a lot of people are saying, I don't have a better source than that, but they are coming for GPT-4. The performance is getting better every day. But the reason why this isn't widespread is that self-hosting is a decision you have to take, and it's a big decision to take. Serving your own models is hard. It's hard for all the reasons that self-hosting things is always hard. But there's a bunch of other ones that come specifically to serving LLMs. One of those is availability of GPUs, knowing how to program GPUs. Your team might not know how to do that. Partitioning your models across GPUs, all of those kinds of things. Fine-tuning your model, you might need to do that. You might not need to do it, but you also might need to build your model into a pipeline. And that's hard to do if you don't have the plug-and-play OpenAI API to rely on. Monitoring and evaluation and logging, that's another difficult task with LLMs in general, right? This is hard with OpenAI, it's hard with open source models too. But if you constantly change your model, it doesn't make it any easier. And what we work on at TitanML, we sell a product called the takeoff server, and it solves some of these problems. It's what we call an inference server. It wraps your model in a REST API, and it contains all sorts of optimizations to make your open source model run faster under the hood. And so I'm going to talk for the rest of my time a little bit about some of the tricks we use to make it easier for you to serve models within the takeoff inference server, and highlight where we rely on open source and where you can use some of those same tricks yourself if you're trying to build an equivalent. And so here's a little start at an LLM serving toolkit. 4 of the things that you might need to build if you wanted to build your own API server. So first of all, batching. Batching is something that's super important if you want to serve LLMs at scale. The problem is, it's GPUs and accelerators of all kinds, GPUs, TPUs, blah, blah, blah. These are massively parallel processes. You have thousands of cores, all of which can compute at once. And the problem of optimizing the performance of an LLM isn't a question of doing less work. It's figuring out how to make the work you have to do parallelizable, so you can do it all at once. Right? And if you just send single requests in, if your users are just interacting with your ChatGPT, your AI application, they'll come in one by one. If you process them one by one, you won't get the scale and the serving capability that you need. And so you have to batch them up somehow. and you have to join them together. And there's a couple of techniques that we use to do that, and that you can use to do that as well. And the first one, and we don't have to get into the details of the technical diagrams here, but dynamic batching is a solution. So one thing that you can do if you want to batch together requests so your LLM can process them all together, is you can do dynamic batching. And that is you take your first user, sends in a request, you have a fixed interval, a window that you wait, and all the requests that come in that window you process together in the LLM. And so each user waits a little longer than they would have done otherwise, but it increases the throughput of the server, and that's the point. So each user, the average user doesn't wait as long. And so the scale that you reach when you deploy your model like this is substantially higher because, yeah, this throughput latency trade-off, you make it in the correct way for the model you make. There are lots of problems with this strategy. This is what is quite widely used in the sort of serving field, especially before some of the more modern inference server technologies. It does increase latency, and that's substantial. And you have to wait to process. It operates at the request level, right? And so users you ask ChatGPT a question, and you wait for the whole response. And then once that response is finished, like your whole batch will process a whole batch of responses. All those responses will finish. It will then pull in a whole new batch of responses, and they'll all go to the end. But if some of your users are asking short questions with short answers, some of your users are asking questions with long answers, there's all kinds of wasted effort that you're putting in that you don't have to do because those users with short answers are stuck in a batch that's being processed with these long answers. And so the next step on this journey of making the highest performance, the highest throughput server you can possibly make is to get into continuous batching. And the idea is that generation, the way the LLMs do it, is a token by token activity. They send you back tokens, words, effectively, one by one, and they process them one by one. And so in principle, you're decoding, your new sequences can join at the next token that's being processed. They don't have to wait. And so you can have a batch that constantly it grows and shrinks over time. And this lets users join the batch in progress immediately, right? And this is one of those things that's, if you want to serve at scale, you want to make sure your model works perfectly, you need to think of these tricks at this token level. And so that's still about batching. Another thing, so output constraints. And so Tuana talked a lot about output constraints for API models. And people have tried all kinds of things, some smart and clever and careful, like retry loops that Tuana was talking about, and some slightly less scientific. And so I don't know if people have seen these. This was way back when, if you threaten to take human life, then the JSON you get out of BARD is significantly better, right? ChatGPT will offer much better responses, much better JSON if you offer it money. Which, it works, but there are probably better ways of doing it, right? And so retry loops is a good example of something you can do. But if you can get in at the guts of the serving structure, you can do much, much better than that. And again, I have a habit of putting too complex diagrams in my slides, so probably best to ignore that one completely. But the point is that you can modify this LLM decoding process internally to make structured output generation the natural behavior of the model. So instead of just generating whichever token the model thinks is correct and should come up next, you take this global problem of wanting JSON to come out of your model, and you break it down into a local problem that your model is forced to solve. So you have JSON so far, you've created an open brace. Whatever your model outputs next has to be valid JSON. So it has to be a string character, has to be a double quote character. And once you've generated your double quote character, it has to be a valid string character, and et cetera, et cetera, et cetera. You hook it into the decoding algorithm. And because it's an open source model and because you're serving it yourself, you can do this. And this means that you output JSON correctly first time according to a schema that you provide. And so you get this performance. And the reason that you get this performance is because you're doing it yourself. These diagrams, just to go over them completely, there are some interesting technical details that come with this. LLMs generate tokens, clumps of letters. But when you want to talk about JSON as a grammar, as a way of generating text, you have a tree of characters, right, at the character level. And so you have to turn this string of characters into a string of tokens, and there's a constant mapping between the token level data and character level data. It's all very, very interesting. And here you can see some of the open source attempts to solve this problem at this AI, at this deeper level in the generation loop. LM format enforcer is at least my favorite. I think it's the best way for doing this. And it also lets you do very many more things. So large language models, open API only ones, are very, very good at generating JSON because there's a lot of that in their training set. But one thing you might express your desires in you might want some structure from your model that isn't in everyone's training set. So for example, you might want it to be valid SQL. You might want it to match a regex. You might want it to match the technical term is context-free grammar, but there are tons of ways you can express this, and so you can do that if you hook into this loop. And so another one you might have heard of, another thing that you can do if you have your own local model, quantization. And so the trick here is that these large language models, I mean, it's not really a surprise, they're very, very big. The problem is with serving them is that they are so big, right? They're multi-GPU, they're multi-node, and how can we make them smaller? Quantization is a trick that we use to make them much, much smaller and run faster if possible. And the reason you can do this is that LLMs internally are somewhat fuzzy. It's a different kind of computation than the kind we're used to. They are the result of a complex multi-dimensional optimization problem. And so they're kind of in this fuzzy space of correctness. And if you mess around with your model a little bit, that's not going to ruin its performance, but it might speed it up massively if the way you choose to mess around with it is to turn your weights from these kind of very precise floating point numbers into these less precise but easier to manipulate integer numbers. And so you do have to be somewhat careful. You have to make sure you maintain performance in the correct way. And again, I've highlighted some of the open source libraries that are available for solving these problems here, AutoAWQ, GPTQ, and then there's repositories of these models as well. And so one last thing that's very, very useful is caching. And this is very familiar from serving self-hosted applications in the normal way, so not LLMs. Caching is a way of saving expensive operations that behave the same twice. So you have your application, it makes some query to a database, or an LLM in this case. But that query always has the same answer, right? And since it always has the same answer, if you've asked the question before, we should store the answer and then return that very quickly. That's what caching is. But caching for LLM serving is very, very hard to do because how often do you say the same thing twice in your life? The answer is, well, somewhat frequently it might feel, but in practice, not very frequently. There are exponentially few times when this happens if you have an LLM production. And so you can't naively cache it. You can't say, my question last time was this, my answer last time was this, because your users are going to ask different questions. And so what you do is you store everything the LLM has ever generated. And if you ever see the same context again, you ask the LLM to check whether the thing it said last time is the right thing to say. And the trick here is that LLMs are significantly faster at checking than generating because they can look at everything they said last time in parallel. And again, this is this point about having GPUs. You can look at everything in parallel much more quickly than you can look at things one by one. And there's many, many more things that you can do here. It's my favorite thing to talk about. So if you want to talk about this afterwards, we can get into that. But there are tons of tricks and tips. And I think to take away from this, if you do want to serve your own LLM applications, you should. It's worth doing. Open source models are brilliant. You can build brilliant applications. You should think carefully about how to serve them yourself, right? There are tons of things you can do. There's tons of open source options. It's definitely worth doing. If you don't want to think about these things, then come and talk to us. We'll help you do it. And with that, thank you very much. Questions? Yes. Sorry, yes.
Thanks for the talk. Basically with batching, how do you ensure that the context is isolated so that no one is querying like is leaking data? For example, if you have like multiple queries.
It's a very good question, and one that we've been asked before from people. It's really a question of careful thought. Under the hood, batching is effectively a for loop, and each iteration, if you're a programmer, that makes sense. If you're not, it might not. Programmatically, these are independent applications of the model, and so if you check the code again, which you can do because you provide your model as open source, you can see that there's no way for information to leak between different sequences.
Thank you. Hello. My question's about model parallelism. Does the takeoff server decide for you your distribution strategy, or is that composable via some kind of interface? Like if I'm running a Mixtral or some kind of like mixture of experts model, I might want to do something like experts parallels. But if I'm running like, I don't know, just some dense like decoder only language model like Mistral or any of the others, I might want to do like tensor parallelism, data, or any of the others. Do you decide that for me, or can I choose?
That's a very good question, a very technical question. At the moment we choose, not as a matter of principle, just because for Mixtral it's faster if you do expert parallelism, and for Mistral there's no notion of experts, and tensor parallelism is the fastest way that we know to serve it at the scales that it's available at. But that's a discussion. If you have evidence it's faster the other way, we can build it that way.
Yeah, so just curious, do you do you have within VPC AWS deployments, or how is it hosted?
Yeah, so that's the glory of this kind of thing, is you can choose. So yeah, within VPC is easy. It's containerized, right? So an inference server, at least the way we build it, is a container that runs your LLM. So if you have a VPC that has GPU enabled machines in it, then you can deploy LLMs in it.
And just sort of a quick follow-up on that, like, can you also run it in Inferentia machines, or is it only GPU?
So GPU only at the moment, but we're building out Inferentia supports on our roadmap, and so it's something we can do. Okay, so 3 questions only, so thanks very much. Let's talk afterwards. Yeah, okay.
Hi everyone, I'm Isabel and I work at Jina AI in the model tuning team, and we're based in Berlin, so I quite literally flew in just for this event tonight. And tonight I want to tell you a bit about training embedding models, what embedding models are, and then finally hopefully what they're used for in the wild. So first of all, a show of hands, who knows what embeddings are, like on a general level? Okay, cool. Well, it's also okay if you don't, because I did prepare a whole slide for this. So basically, an embedding is just a vector of numbers, right? And if your model is any good, it can create a vector of numbers that is a particularly good representation of your input, such that similar inputs have similar representations, and different inputs that differ semantically have a different representation, and different in the sense of mathematically, if you compare those 2 vectors, they have a higher similarity score or a lower similarity score. That's the basic idea, but I think you guys will probably already know that. So some applications we've already spoke about similarities. So vectors are really nice, or embeddings are really nicely used for semantic search. So you encode your entire index, and then you have a query incoming that you also embed or encode, and you can compare that to your index and retrieve similar documents. That's really cool because if you have a modality agnostic model, you can input a text query and retrieve similar images, for example. yeah, and for clustering, maybe you have a whole bunch of news articles you want to cluster by topic. You can easily do this cluster by, I don't know, politics, finance, and stuff like that. This analogy extends quite nicely to recommendations. So similar movies, you might want to recommend someone Inception if they enjoyed Shutter Island, just as an example. Cool. So why did we, as a company or Jina AI, decide to go into embedding models? Or we wanted to, first of all, create a general purpose embedding model that is pretty good on most downstream tasks. So there's a really big benchmark called the Massive Text Embedding Benchmark that has a whole bunch of different downstream tasks ranging from classification to retrieval and re-ranking. And we wanted to build a model that just does well overall. And of course does well, especially in retrieval, because that's what embeddings are mostly used for. And we also wanted to try be state of the art. So we did try to get in the top 10 on this leaderboard, the MTB leaderboard. Thirdly, we, as Jina AI, also are very passionate about open source. So we wanted to make models that we open source to the community. And it's really great to see what comes out of that, because there's so much collaboration and people take them and fine tune them. It's great for the space. Fourthly, we wanted to allow input sequences that go beyond the general 512 tokens. So most embedding models before we released ours could only take 512 input tokens. And we made it our goal to implement Alibi. Maybe you've heard of it. And so this allows us to take input contexts of 8,000 and theoretically more. And last but not least, we also wanted to go into bilingual models because we've seen that multilingual models, which are trained on a variety of different languages, don't really do so well on any given language. So we really saw a market need that people wanted in English, embedding model, as well as like one other language, for example, French or a local language. Cool. So I'll lead you quickly through this, or try to lead you quickly through this training process, going all the way from training our own BERT model all the way to fine-tuning our Jina embedding models. So of course, you need a huge amount of text data to get this Jina BERT model trained. So we trained it on the C4 corpus or dataset. And basically, the way the model learns is you take 30% of the tokens in your documents and you either mask them, leave them unchanged, or you replace them with a random token. And so the model learns to unmask the masked token and learns what the correct probability is for the next token, given that. The next stage is pretty important. This is the pairwise training data step. So what we do is we have this bi-encoder two-tower architecture where we have two BERT models and each get one part of the pair. And the pair you can think of as two sentences that ideally belong together. So that could be a query and a top document that should be retrieved for that query. Maybe it's a title and a passage, or just a question and answer, for example. And the idea here is to minimize or first of all, maximize the similarity of the representation that sentence A gets to the representation that sentence B gets. And then also to minimize the similarity of sentence A with all other sentences in that batch. And so you can drive apart the representations for sentences that don't ideally belong together. Cool. And then for the last part is pairs plus an extra component, which is a hard negative. So besides the pairs that already belong together, we add this hard negative component that also should be pushed away from the original two pairs. And we also have in our training or in our loss function, we accommodate for this to be multiple negatives, which is really important so that you can see, for example, in this example, London is a city in which Canadian province? And then the first, in this case, the positive answer is Ontario. And then we have three more technically could be answers, but they're wrong. And so the model should learn that although Quebec is quite similar to Ontario, in this case, it is a negative, a hard negative. So that's a really important part of the training. So how did we go from monolingual models to bilingual models? Well, the training process, can I hide this? Anyway, yeah, so the training process stays quite the same. Literally, the only thing we do is we change out the data. So the Jina BERT model is then trained with 50% English data and 50% of the other language that you want to train for. And then for the embedding pairs, we also take like a 2/3 English, 1/3 the local language or the language you want to train for, and then 3% parallel data. And this is quite low because there is really often quite not that much parallel data. It's hard to come by. Yeah, and for the last step, we have 1/3 English data, 2/3 of the translated triplets from our original step, and then 3% originally these hard negatives that come from the language you want to train for. And very exciting, we've published Jina, the English model, the base model has been published since November last year, and then we have 2 more languages here, or bilingual models. Unfortunately, you can't see this, but this is the Chinese model that you can go and have a look at. So one German English bilingual model and one Chinese English bilingual model. Oh, okay. It's hard to do with one hand. There we go. Now I can't change the slides. Oh, there we go. Okay. So another motivation for bilingual models, I guess I already explained this. We wanted to have support for English as the dominant language, and then another language, a second language that was desired, for example, Chinese or German. And it's easy to do because we've already got the English data, which we've proven does really well for training our models. So we just add another language to it and it does magic. And here you can see the magic. So we compared our bilingual models on English to German tasks, cross-lingual tasks, to multilingual models, for example, MBERT or XML-R, which is a Roberto multilingual version. And it's nice to see that, yeah, our model performs better than the multilingual ones, which are trained on various different languages. Another cool case of evaluating our large or our base model is a paper that was published actually this month, very recently, where they tried to see, well, how good is your generalized model on a very specific use case? In this case, it's a data set of clinical code descriptions from the medical domain. And it's good to see that Jina Embeddings does really well, in fact, better than clinical models that are specialized and trained on the specialized data. So how would you use embeddings in production? Well, we've already seen some flows of embeddings, for example, in a retrieval augmented generation pipeline, but this is a really just simple search use case. So you encode, of course, all of your data with an embedding model. For example, our models are hosted on our Jina API, but they're also accessible on Amazon SageMaker. And then you get to store all of those embeddings in a vector database of your choosing, for example, Weaviate or Quadrant or something like that. And upon query time, of course, you need to encode that query as well and retrieve similar documents. And most importantly, also, I guess, to make a connection to Haystack, we've got great integration with Haystack where you can just add one of 2 components, the Jina text embedder or the Jina document embedder, to your pipeline, and you can encode embeddings or generate embeddings with your pipeline. For example, in the retrieval augmented generation setting across legal documents, here's a quick snippet to show you how to run. Yeah, you'd have like a text embedder component and get to generate a nice answer. I will skip this diagram since we've already spoken about retrieval augmented generation a bit, also by Tuana. But another use case also is quite nicely shown here from Llama Index, actually published this blog post highlighting how Jina embeddings are really useful or do really well in performance when they're combined with re-rankers. For example, the BGE re-ranker or Cohere's re-ranker, and we've got really excellent performance with those. I think this is the last use case. So in the community, someone recently used our models to encode all of the model cards on Hugging Face and visualize these in a deep space. and it's quite cool actually if you want to go check that out. I assume that these are also clustered by datasets that the models have been trained on, and the use cases that they can be used for example, vision models or text pure models. Yeah, I think one more thing is the LOCO benchmark. So this benchmark was published also very recently, and with it, they published a long context or long document benchmark where you could see the performance of your model on longer texts. So ideally, probably your model was not trained on very long sequences, since it takes a lot of compute. And yeah, it's good to see that Jina Embeddings does really well, given that it's not fine-tuned on the LOCO dataset. It performs really well. Cool. And before I go on to any questions, I think I will pose a question to you guys. So can anyone tell me exactly what the acronym BERT stands for? Yes. Great. So I have a swag for you that you can come pick up. A swag bag. Cool. Yeah, thank you. I'd be happy to hear your questions if you have any. Yeah. Big.
Yeah, just a question, because I saw you build the triplets with multiple negative samples. So which kind of loss do you use, and what's the idea in case one of the negative is difficult and the other are too easy? Would it make probably more sense to split the triplets and then select the more difficult? Just to understand a little bit the idea.
So good question. So these hard negatives are actually mined by the pairs model from the previous step. So the model is actually teaching itself which documents are hard so that it can learn to distinguish them better. So these triplets or these negatives that I have here would be mined from the previous step with that model.
Yeah, and which kind of loss do you use to combine to allow to have multiple negatives? Because the classic triple loss only allow one negative, where you can think of averaging the negative.
We've got a modified info NCE loss that can take up to 15 negatives. And so they can vary also. We have sometimes for a triplet, we only have 3 negatives, and sometimes we have 7 or 15. So we have an info NCE implementation that can take care of this loss.
Okay, thank you.
Yeah, firstly, really cool stuff. The interesting part in there is like the context that you can process. So as you say, like 8192 is a big number. Do you know of any work that basically can look for, as more of these like long context embedding models are coming out, do you know if anyone's looking at kind of lost in the middle bias? So I mean, like we have things like passkey retrieval for large language models where like you bury a substring halfway through a very long piece of text and kind of look at the hit rate. Is there any kind of like analog for that in embeddings?
Yeah, so I think it's becoming common knowledge that embeddings will do a lot better for retrieval if the important information is either at the beginning or at the end of your text. So maybe that taps into this kind of lost in the middle thing. If you have important information, for example, at the middle of your text, then that might easily get lost. I'm not sure of any approaches that fix this. I'm sure there are some attempts. There's another question at the back.
I don't know if I'll be breaking any rules by asking 2 questions, but you can feel free to answer just one of them.
Okay.
So thank you very much. Very, very, very interesting presentation. A lot of the MTB leaderboard embedding models that are used, or a couple of them at least, use instructor based. So you put in an instruction and encode it together with your query, and you basically tell it what kind of embedding you are getting. And is that a technology that you, or is that a something that you're looking at doing or have looked at doing and decided not to do? And then my second question is about fine-tuning on domain-specific embedding models and whether that really is likely to achieve good results, or whether domain-specific embedding models are kind of a waste of time to the extent that it's not really making much of a difference.
Yeah, I will answer your second question first, just because it's fresh on my mind, and I've basically already forgotten your first question. But yeah, so I have seen personally also some cases when out of the box general language models don't do the job. And for example, very much in the e-commerce domain, I've seen that models like Clip do really, really badly because they're really trained to be general and to look at the whole picture in quite a literal sense. And so if you have an image where you actually want to pay attention to the clothing rather than the face, this can be really problematic for general models like Clip to take care of, because maybe you post a picture or you search with someone who has dark hair and identifies as a man, and then you literally only get retrieved results with the exact same features. So this is the kind of domain-specific problem where we like to fine-tune on domain-specific data. I think the e-commerce is quite a good example of that. Yeah, so in that sense, I don't think that they're all one size fits all. And then for your first question.
Instructor.
Yeah, so we actually haven't done too much experimentation ourselves. We decided very early on to step away from this complexity, though we do see very clearly that the models that do implement this do better. And so if you look at the E5 models, they have this instructor component at the beginning that it just, their performance is quite a lot better. And if you evaluate that model without that prefix, that instruction, it just does quite badly, like up to 10% or so worse. So we are definitely putting some resources into adapting our models or bringing out a new version of our embedding models to accommodate this. And there's also a running joke in our team saying that, well, so if you look at OpenAI's embedding models, they have an input length of 8191 instead of 8192. And so we like to joke that they're probably pre-pending some stuff there. Yeah. Cool. I don't know if we have more time for a question or.
Thank you. So yeah, the question that we have online from Zoom is a fully multilingual embedding model something like Cohere Multilingual V2 on your roadmap, even if the sequence length is not 8K? Very specific question.
Yeah, I don't think that those two things are mutually exclusive. I think if we did do a multilingual model, it would also have 8K context length. I don't see us training a multilingual model anytime in the future. I think we have found a niche of perfecting bilingual models. And so, yeah, I don't see it in the roadmap anytime soon.
Any more questions?
All right, with that, I think we can at least wrap it up for anyone attending on Zoom. I'd like to thank again the two other speakers we had, and we have some more time here, so please feel free to come up to us and ask any questions you had remaining. But we'll probably end the Zoom call now. There should be more drinks and maybe some more food that's going to be coming around as well. So please enjoy yourselves and I hope you have a lovely evening. Thank you very much for coming.